Everyone. My name is Ashwin, and I will be talking to you about context engineering with Redis. And when we talk about context engineering, we are fundamentally addressing the core challenge of AI agents, how to make them fast, practical, and cost-effective today. So now when you hear an AI agent, some of us are probably imagining sleek Jarvis-like systems, making decisions and taking action with perfect intelligence, right? That's kind of the wrong picture. In reality, agentic AI is still crude and unpredictable. It is powerful, yes, but often it's messy and it's costly. And it's also often in need of structure because every agent workflow involves multiple large language model calls, tool executions, and state management. And without the right architecture and context, your agent quickly just becomes another expensive chatbot. It's going to burn through tokens and it's going to give you deja vu answers. So that's what we are here today to talk about how to actually make agents practical, fast, and cost effective with context engineering. So just a quick intro about me. I'm a developer advocate at Redis, where I build AI systems and explore patterns around performance, scale, and real-world applications. Prior to Redis, I've had 10 years of experience as a full-stack software engineer. And for those who may not know, you probably are aware of this already, but I'll still state otherwise. Redis is an open source in-memory data structure store. It's used as a database, both conventional database, and now we support vector operations as well. It's also used as a cache, and it's also used as a message broker. And we're going to see today how its high performance, high speed capabilities are essential for powering the modern AI stack. And so my goal here is to show you what smart context engineering with Redis looks like in action and how you can use that to build a complete, working, very usable AI agent. Okay. So here's what you will learn. So firstly, we'll start with, what exactly do we mean by an AI agent? Why is there all the buzz going around it? And what are the key components? Okay. And then we're also going to go through some use cases of AI agents. And then we will see an actual demo of an agentic AI in action. And then towards the end, we'll talk about how we can use Redis to provide the necessary context in order for this AI agent to work effectively. We'll talk about agent memory server. We also will talk about a few other concepts which are important for production use cases, specifically semantic caching. And we will look into some key considerations like frameworks and the next steps. All right, so one more thing before we begin. I also want to challenge a few misconceptions along the way. So just like me, so I come from a full stack web development background, which is to say I did most things with the JavaScript and TypeScript programming language. And I did not have a prior AI experience prior to Redis. So just like me, you do not need to necessarily be an AI engineer in order to build an AI agent for your app. So besides knowing a few concepts related to context engineering, you do not need to know in excruciating detail how it all works under the hood. And so I can build with whatever programming language I want. So if there's any takeaway from this talk, you can use whatever language you currently use at your workplace. Okay. So that being said, so we'll start. So when we talk about AI agents, what exactly do we mean? So it felt to me like the ultimate in buzzwords, right? Like everyone is talking about agents, but if you quiz them, then everyone seems to hold a different mental model. Okay. So here's how I like to think about it. An AI agent is a system that uses a large language model to decide the control flow of an application. So it's basically a system with a large language model which has capabilities beyond just searching for information or acting as a substitute for Google search or generating text. It's not just a chatbot that responds. It's a system that can actually do things on your behalf. It can take actions. So think of the early days of ChatGPT, how it used to be. So back then, ChatGPT a few years ago was like having a really smart consultant who can give you advice, right? Now it's evolved to something more than just a chatbot. It's an AI agent now. So an AI agent is like having an assistant who can not only give advice but can also execute on it. So for example, book that hotel room or file that support ticket, or maybe update that database. Okay. So here are a few examples. Like for a customer support chatbot would just, if you ask it how to reset your password, so it's going to just give you a bunch of instructions. Whereas if it's an AI agent, it can actually send you a password reset email. And similarly, in a e-commerce shopping example, a chatbot might just give you a pull-up information for you and just tell you, here are the items that you're looking for. Whereas an AI agent can add things to your cart, it can apply coupons, it can, initiate the checkout process. And if you have any questions related to refunds, so it can, even direct that to a refund workflow as well, right? And similarly, coding examples, right? Like for example, initially, if you use ChatGPT and if you ask, here's my program and it's not working, and it's just going to give you a bunch of instructions. Whereas now you have Claude AI, you have GitHub Copilot, they can actually write code for you, and it can test the code for you and can generate a PR with the fix. So that's the difference between an AI agent and a chatbot. Now, before we dive deeper into building an AI agent, I want to just talk about this word agentic. Everyone is throwing it around, but what does it actually mean? Um, so here's what Andrew Ang from deeplearning.ai says. So uh, here's the best way to think about it. A system is more agentic the more the large language model gets to decide how the system behaves. So it's not just a binary, it's a whole spectrum. Okay. And speaking of spectrum, here's what the spectrum looks like. On the left-hand side, as you see, we have something like a very simple router. Now, this is barely agentic, right? The large language model is just going to look at an input and decide what downstream workflow to send it to, okay? So, for example, think of a customer support bot that reads your message and decides, is this about billing? Then route to billing workflow. Or is it a technical issue? Then route to tech support workflow. And is it a return request? Then route to returns flow. So there's one decision and then a predetermined flow takes over. So the large language model isn't making any more decisions after that initial routing. So that's on the left-hand side. Now, if you keep going towards the right, the system gets more and more agentic. For example, in the middle, you have a model-based reflex agent. That's a slightly more advanced version of the simple reflex agent. It can incorporate an internal model of the world. And here's where context is important. So this context is going to help the agent track the current state of the environment and understand how past interactions might have impacted it. And that allows it to make more informed decisions. Okay. And moving along, we have something like state machines. Now things are getting a little interesting. Multiple large language models making multiple routing decisions. One of them decides to whether to continue or to stop, or whether to let the system run in a loop until it's finished. So this is where your GitHub Copilot or Claude AI chat that comes into play. It can decide to look at your code, propose changes, check if the changes make sense, revise them, and it can continue this loop until it has a working solution. And each step involves a large language model decision, but the overall flow is still somewhat structured, and all of them require context. And at the far end, we have autonomous agents, right? And these systems are building their own tools, remembering them and using them in future steps. For example, the Voyager paper's Minecraft agent is perfect here. So that agent can actually explore the Minecraft world, and it can encounter, whenever it encounters a new challenge, like I need to cross this river, it's going to write its own code to solve it. Like it can write a bridge building function, and it can save that code as a new skill. And later when it sees water again, it can remember and reuse that skill. So it's combining multiple self-created skills to solve complex problems. So that's a spectrum. Now, every AI agent, regardless of where it sits on that spectrum that we just saw, it has three fundamental components. First is the memory module. Now, memory is split into two parts. For example, imagine a travel agent, okay? Short-term memory knows that you're currently planning a trip to Paris next week, okay? Long-term memory knows that you always prefer window seats, if you're vegetarian, or maybe you usually book morning flights. So one is session specific, the other is going to persist across sessions, okay? Next, if you see in the screen, that's the reasoning module. This is where the large language model lives. This is the brain, okay? It's going to take all the context from the memory layer. It's going to analyze the current situation. It's going to weigh different factors and evaluate probabilities and then decide what to do next. So think of it this way. When you ask an agent, for example, find me a good restaurant, the reasoning module is considering what cuisine does the user like from the memory, what's nearby from the context again, what's the budget based on previous conversations, what time is it? Is it dinner or lunch? So it's not just pattern matching, it's actually reasoning through the decision. Now, the key thing here is that the large language model isn't just generating text, right? It's making decisions about system behavior. You know, should it search for more information? Should it ask a clarifying question? Or should it execute this action? So that is reasoning. And finally, we have the tools or the action module. This is what separates an agent from just a chatbot. This is what makes an agent actually useful because it can do things, not just talk about it. So broadly speaking, you can think of it as tools being three separate categories. Like one would be API integrations. So this would mean that the agent can query your database, call web services, interact with third-party APIs. So when you're asking an agent to check if the product is in stock, it's actually making somewhere a database query or an API query. It's not just guessing. And then you can have digital interactions, which would involve sending emails, updating user interfaces, processing transactions, generating documents, real actions in digital systems. So when your GitHub Copilot modifies your code, that's an example of digital interaction. And then you can have, it can also involve physical environment. Now, this is where it can get a little sci-fi, but it's actually very real, robotic controls, IoT devices, sensors. It can control a character maybe in a virtual environment. But this can also be a robot arm in a warehouse or a smart home system adjusting your thermostat. Okay. Now, if you notice all these arrows in the picture, so this is not a linear pipeline. So information is flowing in cycles. Okay. Memory informs reasoning. Reasoning triggers actions. I should do this. And actions once again update the memory, that maybe the agent learned something through its actions, right? Now, let me show you how all of this works in practice. I have built a shopping assistant that demonstrates every principle we discussed. So you're going to see semantic search, caching, and agent orchestration and persistent memory. They're all like working together, okay? Now, before I show you the agent in action, let me sort of just pull back the curtain and just show you what's actually powering it, okay? So I'm going to go and type, I'm just going to run the server, okay? Now here, this tool that you see right here, this is Redis Insight. It's Redis's free developer tool that lets you see exactly what's happening inside Redis. Okay, so it has a CLI, it has an AI-powered assistant, and it has this intuitive user interface that makes exploring your data and debugging so much more easier. So you can browse, you can debug and inspect your Redis keys easily. So if you're developing features with Redis, this is a fantastic tool. So now let me show you what our agent is actually working with. So here, as you can see, this is our product database. So if you look at the structure over here, okay, see this. So we have like thousands of real products, everything from lunch boxes to vegetables to groceries and spices. And every product has a structured data. It has price, category, brand, description. Okay. But if you notice this particular field over here on my screen, product info embeddings. So these are vector embeddings. It's 1,536 numbers that capture the semantic meaning of this product. So this is what enables semantic search. So when, for example, if someone over here, this is a steel lunch box, okay? So if someone over here in our app is searching for lunch container or tiffin carrier or food storage, they are all going to find this product because the meanings are similar, okay? So we have products across all categories: kitchen items, fresh produce, groceries, everything you would find in a real store. So this is not a toy data set. This is a data set that I pulled from a very popular retail company called Big Basket. And this is available as an open data set. So that's where I pull this out of. So now what I would like for you to watch for is how the system understands context when we use the AI agent, and it finds relevant products even with vague descriptions, and how the system gets faster over time as it learns from previous interactions. Okay. So back to our demo. Okay. So now here on my bottom left hand corner of the screen, this is my um, this is where I'm going to interact with my agent. So it's a chat interface. So I'm going to start with a complex cooking question. Okay, so I'm going to ask, I am looking for pasta ingredients. Okay, so I've hit enter, and this is my terminal. Okay, so notice that this is taking a few seconds. So the AI is thinking through the recipe, understanding what pasta requires, and then it's searching through our product database that we just saw to find actual ingredients that you can buy. So you can notice that on my terminal, it's trying to use a certain tool called Fast Recipe Ingredients. That's a custom tool that I've written. So it's going to take a little bit of time because it's a cooking question. It has to break down your question into ingredients, and then it has to do a product search. Okay. So now if you notice over here, look at this on my screen. It gave me a complete ingredient list and found actual products with IDs and prices. And these are actual products that it found from the database. It's not hallucinating. To verify, we can actually click on this icon, and here's how it looks like. So here's how a product description looks like. Okay. Now, let me show you how this looks like in Redis inside. What just happened? Okay. So I'm gonna hit a refresh. Okay. And now this part over here, as you can see, this is a user session. Okay. This is going to help keep everything for a session self-contained and isolated. And this is my chat conversational history. So notice that how we are maintaining the entire conversation here. Every message, both from the user and the assistant, is stored in order. So this is the short-term memory we talked about earlier. So the conversation is stored. Now the agent can now refer back to this context. Now this enables me to list chats, update individual conversations. It also allows me to delete an entire session easily. Okay. Now, if you notice one more thing, if you notice this cart information over here, this cart object is empty right now because this user has not added anything yet. Okay. Now we will do something here. Now we will try to interact with the agent, and we will try to add something to our cart. Okay. So I'm going to go back to my, so I'm, by the way, logged in as a user called Ashwin. So that's why our session that we just saw was also stored by the same name. Okay, so now I'm going to say something like add item one, items one, and that's going to be pasta. And like I don't have onions, I have everything else. So I'm just going to add items one and three in my cart. Notice that I do not need to mention the entire product name at all, right? I just need to, the agent is going to figure it out like based on the context. So I'm going to ask my agent, and now you can see my terminal. So it's using a tool called add to cart. Okay. And once you go back, the agent replies saying that it's added, the products that we wanted to our cart. So you notice that it's used the product ID from the previous search. Let me just show you that. So if you go back to our Redis insight, and let me just hit refresh over here. Okay, so if you notice, our cart object has two items, product that was the pasta, and then the other one was onion. Okay, so notice that it used the product ID from the previous search. It remembered our conversation context. This is an example of context engineering in action, because the agent has access to our product database for searches. It had access to our conversational history for context, and it also had access to the cart state for the current status. And all of this is instantly available through Redis. Okay, so now going back to, let me just say, view my cart. What's in my cart? And it's going to reply. Here's what's currently in our cart, right? So this is session persistence across the entire conversation. It knows who I am, and it knows what I've been doing. Okay. Now let me ask you something. Let me ask you, have you ever Googled how to cook something? So just maybe think about it. Maybe you've, looked up a Google search, how to cook your favorite recipe, how to make pasta, or how to cook rice. What about something even more basic? A research study that came up a few years ago showed that a question like how to boil an egg was rated one of the most consistently searched how-to queries worldwide, year after year. It's very surprising, right? It's very basic. But then this research project by Google Trends showed just a few years ago that people were looking up, answers to basic questions like these: how to boil an egg, year after year. Okay, millions of people asking the same question. Okay, now what does this tell us? Let me just go back to my slide. Okay. So when you introduce a large language model into your application, whether it's customer support, shopping assistance, technical documentation, it's very likely that your users are going to ask questions that have been previously answered over and over again. Okay. For example, what's your return policy? Or how do I reset my password? FAQ style questions. What are the business hours? Or how do I export this file to PDF? So it's the same question, slightly different phrasing. Different people are going to phrase it differently. One person might say, what are your working hours? Another person might say, what are the business hours? So it's the same question, slightly different phrasing, but it's asked many, many times. Okay. So, and every one of those questions that people ask, it's going to trigger a full API call. It's going to trigger, it's going to cost a bunch of tokens. So it's gonna cost computationally, and same processing time, same expense. And you might end up doing or redoing work that you do not need to do in the first place. Like you have answered that question. That work has been done by the large language model. Now the question is, is there a way to reuse that work that your large language model or AI agent has already done before? Because not all queries deserve a unique response because they might have been asked before, okay? So here's where semantic caching comes in place with Redis. What it means is semantic caching allows the agent to understand that the question, what do I need for pasta or pasta ingredients, they both are the same question, okay? So it does not need to redo the work that it already has done before. Now, let me show you how exactly this works, okay? Now, going back to our demo, so I have logged in this window as Ashwin. Now I'm going to switch to a different window. So this user, by the way, phrased the question as I am looking for pasta ingredients. Now I'm going to go to a different user. This is a different one, new session. And let's ask the same question, but we will phrase it slightly differently. So I'm going to ask, what do I need for pasta? It's the same question, right? But it's phrased differently. And I'm going to hit enter. Okay. So semantic cache recognized the semantic similarity and served the cache response. So it took very, very less time. Whereas the previous time, the first time that we asked the same question, in this way, it took quite some time, right? Whereas this time, we phrased the question, we asked the same question, but it's just worded a bit differently. So semantic cache with Redis, that allows the AI agent to recognize that both questions are exactly, they kind of mean the same thing. And it just served the cached response. So there was no large language model call, there was no tokens burned, and it's the same high quality answer, okay? And if this is very, very straightforward to do. So one of the ways to do this is by using Redis Langcache. That's Redis's semantic caching as a service, which handles all the vectorization, the similarity matching, the storage. So you just need to save and search, okay? So now let me show you how we built this. Now you just saw it working. So let me just show you the architecture in a second. Right. So if you notice here, in this diagram, as you can see, every query follows a cache first pattern. So before we end up doing any expensive AI processing, we check if we already know the answer. So that's where Redis Langcache comes into picture in the screen. That is semantic caching as a service. So we first check in the cache and see if we already have done the answer. We already know the answer or not. And if it's a cache hit, it means instant response. Okay, so we can just serve the cached response directly to the user. Okay, whereas if it's a cache miss, that is when we run the full AI workflow. Okay, and here you can use whatever frameworks that works best for your specific use case. In my project, I've used LangGraph or LangChain. So LangGraph orchestrates all multiple AI tools. It handles all the complexity of coordinating tools or managing state between calls and deciding when the workflow is complete. Okay, so here we have very specific tools available for our AI agent, and each tool does one thing well, and they all coordinate using LangGraph. So there is a direct answer tool that uses OpenAI for cooking knowledge, and it caches responses with long TTL values because recipes don't often change, okay? Product search, there's a different tool that uses Redis vector search to find items even with fuzzy descriptions. So it's going to handle the semantic matching that we just saw in the demo. And then our agent also has access to cart management that uses a simple JSON storage in Redis for session-based shopping. It's very straightforward, but it's effective. And then towards the end, once it's done all of that, we save the result, we cache the response once again so that the next person gets the instant response. And this is where Redis really shines for providing the AI the context it needs. It's handling vector search for product discovery, it's handling conversational history and session management, and semantic caching for performance, right? So 3 different use cases and it's just one database, okay? Now, the beauty of this approach is that the system gets faster over time. So every user makes it better and faster for everyone who comes after them, because the more people use the system, they're going to ask questions, and those questions are going to get cached eventually. And then subsequent users who will very likely ask the same question are going to get, served a very fast response, okay? So Now, for those of you who want to jumpstart your agent development, I want to introduce a project built specifically for this. It's called the Redis Agent Memory Server. So when we discuss the memory module, the essential component, short-term memory and long-term memory, now managing that dual tiered memory, that can introduce complexity, especially as you scale concurrently with many, many users and you need cross-session persistence. So agent memory server wraps all those concerns, all those memory functions into a dedicated scalable microservice. So it's going to provide a clean RESTful API layer over Redis, or you can even use the client library without having to deploy it as a microservice. So it's designed for both. So it's going to allow you to do session management, which is to handle all the short-term conversational context that we just saw in the demo. Also user persistence, managing the long-term memory, like user preferences, historical data, that is going to persist across different chat sessions. So by using this tool, you sort of abstract away the direct database interaction from your core AI logic. So your AI agent simply can make an API call to remember something or to retrieve context. And that way it allows you to keep your business logic and your AI orchestration layers very cleanly separated. And that's kind of a very, a core principle of building maintainable and scalable production agents, okay? Now, the fundamental question when you look at an architecture like this is that, how do I get long-term memories into and out of my large language model, okay? So the answer is to manage memory in two distinct tiers, right? This is what exactly a solution like the agent memory server is built to handle. So we have working memory, which is session scoped. So you can think of this as the agent's short-term focus. It's going to keep the current conversational coherent. And this memory is very fast and it's tied directly to the current user session. Now, its functions are very, very critical to the chat experience that you just saw. For example, it holds the current conversation so that the agent remembers the last few turns of the dialogue. For longer chats, it manages automatic summarization. So that way your context window is always kept small and it's going to be cost effective. So it allows to only pass the essence of the history to the large language model. You do not need to, pass the entire context, the entire conversation from the beginning of time. So it has automatic summarization of the conversation. It also temporarily stores user preferences or facts or important information for the duration of the task, like the shopping cart contents that we just saw in the demo. And also, of course, it supports semantic search with vector embeddings. And this is durable by default with optional time to live, meaning that you can maybe want to persist it for a few hours or a few days or whatever you set it before it automatically expires. So that ensures that your resources, your memory is freed up, okay? And secondly, we have long-term memory as well. This is where we store information that needs to persist across different chat sessions, maybe weeks or even months later. So things like a user's purchase history, okay? Or maybe, let's say if it's a medical application, maybe the user has documented some allergy, right? Or maybe in a shopping context, if they have a preference for a certain brand. So this is persistent factual knowledge that an agent must be able to recall to act as a truly intelligent, personalized assistant. So you need a fast, durable database to serve this memory at scale. And this is where Redis, with its robust data structures and speed, that becomes a very critical part of your agent's overall brain, okay? Next, yeah, I just wanted to show you a little bit of architectural deep dive. This is slightly more detailed architecture. So I wanted to highlight some few things here, how we built this app. So we have our AI layer, if you notice, the LangGraph agent orchestration with all the AI tools. This is where the intelligence lives. We also have our services layer. So I have three different services, product service, cart service, and user service. Now this is pure business logic. Now these services know how to search for products or add products to your cart, they know how to handle user sessions, but they don't know or care that they're being called by an AI agent. Okay, so they are self-contained. And at the bottom, if you see, we have our data layer. This is where Redis is handling semantic caching, vector storage, user sessions. Now this layer just stores and retrieves data for the agent effectively. Now, why does this separation matter? Okay, firstly, we are structuring our system by business components, and we're layering each component with three tiers. So it's a three-tier architecture, okay? Every component has its own API, own logic, and data layer. So this is classic three-tier architecture: presentation layer, business layer, and data. So it's battle tested, it scales, it's microservices friendly. Each layer can be deployed and scaled and maintained independently. And secondly, your AI agent does not need to know the implementation details of your business logic. So for example, if you have a restaurant agent, the agent wants to search for products or restaurants or whatever, it can just call a tool that talks to the respective service, okay? The agent does not need to know if the service is hitting a SQL database or a NoSQL store or an in-memory store. It just knows just give me products matching this criteria. Okay, so the AI agent is just another client of your business service. So this allows you to keep your architecture clean and your AI implementation becomes much more maintainable. So loose coupling between components, that's important. So why is this important? Because if you're having an application existing today, you can just easily add capabilities like with Redis and introduce AI in your application if you already been maintaining this architecture. So you can also switch frameworks tomorrow without touching the AI layer. So if you want to replace Python with something else or maybe replace Express.js, go ahead. So the AI tools interface stays the same. The service layer abstracts it away, right? And this is becoming very crucial to keep your architecture clean. Okay. Now, what did we see all this? This is how context engineering looks like in action. This is really the job when building AI agents. Every decision your agent makes should be informed by context. What happened before? What does the user prefer? What worked previously? What does the system know? What tools does your agent have? And every agent decision needs context from multiple layers. Immediate context, what's happening right now in this conversation. Historical context, what do we know about this user? What patterns have we seen? So without proper context, your agent is just guessing. Okay, and it needs context really fast. That's why Redis comes into picture to provide that sub-millisecond context so that your agent can make informed decisions really fast. Okay, yeah, so this is how it looks like. So short-term memory, we discussed that already. And we also discussed how context retrieval looks like. Redis also supports multiple data structures to support episodic memories, keep your memories and sessions isolated. Every conversation has its own history, and it also has its own tool usage, right? And it allows you to store and retrieve context relevant to the task, okay? And Redis also, we have production-ready integrations with all major AI frameworks like LangChain, LangGraph, Azure, AWS Bedrock, Microsoft. So Redis has integrations with all of them. So you can get started right away. It doesn't matter what cloud service you're using, you'll be able to start building AI applications right away. So here are the key takeaways. So let me just recap, since we discussed this one as well before. So key takeaways, let me just recap what we demonstrated. So in this demo, you saw an agent that enables you to do vibe shopping. So vibe coding. I just showed you vibe shopping. So the agent chose what tools to use, when to search for ingredients, do product search, and how to respond contextually. Now, to build this kind of application and deploy them in production, that requires more than just a smart large language model. And Redis is great to provide that necessary context for your agentic AI. It will help you make context management clean and super fast. Now, this approach unlocks a lot of possibilities, right? Conversational e-commerce, where shopping just feels like talking to a knowledgeable friend, okay? Persistent learning, where every interaction, that just makes the system smarter for everyone. And your AI becomes a lot more cost-effective. It's going to deliver intelligence without breaking your budget. And knowledge is available and reused instantly in milliseconds, right? So try out Redis and let me know what you think. I've also included a couple of links here. You can sign up at Redis University. We have free courses available over there. In these courses and learning paths, it's not, you won't just learn about Redis, but then you will come across patterns that you can apply to anything. Like you can apply to any domain, wherever your users need speed and intelligence with memory and context. And you can just start adding AI to your apps much more confidently. So yeah, that's a wrap on the session. I know this barely scratches the surface of what's actually possible here. And if you're curious about how this would work for your specific use case, or you just want to geek out about AI architecture, you can find me on any of these links. I'm available on LinkedIn, and you can reach out to me on Twitter, or you can just check out some of the projects on GitHub. Yeah, and always happy to chat more about this stuff. Thank you.